Here in this video, I'm not going to talk about what is meterbridge, how it functions, how it is designed. That we will reserve for the next video. In this video, we would like to see, first of all, why do we need meterbridge? What's wrong with our Wheatstone bridge? Why can't we live with the Wheatstone bridge itself, right? So let us see what's the problem with the Wheatstone bridge that we have. So what is a Wheatstone bridge, first of all? It's a combination of 4 resistors like P. We have discussed many videos on this, Q, R and S, in such a way that between 2 junctions a galvanometer is connected, between the other 2 junctions a battery is connected, and we have proved that if the Wheatstone bridge is in balanced state, that means if there is no current passing between these 2 junctions, if you name these junctions as something like, say, A, B, C, D, if the Wheatstone bridge is in a balanced state, that means when no current is passing between the junctions B and D, or in the other way, potential at the point B equal to potential at the point D, or delta V between them equal to 0. When this is there, we can say P by Q equal to R by S. Or when P by Q equal to R by S, in reverse also you can say vice versa. If P by Q equal to R by S, there is no potential difference between the points B and D, no current flows through them, right? So to get this bridge balanced, this has to happen. P by Q equal to R by S. This is quite easy to say it on the paper. You make P by Q equal to R by S, the bridge gets balanced. But how do you make it? With what resistors it happens, for what values of P, Q, R and S it happens, we never know. So you have to keep on experimenting and keep on changing the values of all 4. Of course, if all 4 is practically difficult, say for example, if you keep P, Q, R constant, keep varying S till you get the balance, or vary any of the resistors or any of the combinations to get the balance. You don't know when it comes, for what value of S it comes, so it will be, you will be keep on changing from where to where? From minus infinite to plus infinite, or say at least some 0 to infinite in the other way. So you have to vary from 0 to infinite. The value of resistance has to be varied from 0 to infinite. So you test with 1, see whether you have got a galvanometer 0 deflection or not. You have not got it. Test with 2, test with 3, test with 4, and keep on testing until infinite, till you get that bridge is balanced. See how laborious the process is, but there's a big catch. Even if you are able to get it, say for example, you have tested with 3, then you have moved to 4, but we don't know, the balance will be somewhere in between 3 and 4, so you have missed it altogether. So not to miss it, from what you have to do, after 3 ohms you have to put 3.1 ohms, you have to put 3.2 ohms, you have to put 3.3 ohms. Means what? Between every 2 resistors now 10 more readings. Hope you will get a balance, but who knows, you may be still missing it between these 2 also. If you don't want to miss between these 2, you have to do what you have to do, 3.01, 3.02, 3.03 till you get 3.09 and then 3.1 ohms. You keep on testing like this till your lifetime. You will never know when you get the balance, right? I'm just saying an example that you may not be even getting between, somewhere in between you may be getting it. Then again you have to do like 3.010, test it, 3.012, test it, have you got a balance or not, keep on testing. So the possibilities between these 2 0 to infinite resistors are infinite, more than infinite in the other sense to say. So you have to find out for each of the resistance you have to keep it in S for each of these resistance. So change it. See whether your galvanometer has got a zero deflection or not. No. Then change it again. Look into the reading. See how laborious and tiresome the process is. So though theoretically it looks wonderful that vary one resistance and get this balance, you will get this condition satisfied, you get the bridge balanced. Practically there is wonderful difficulties, great difficulties, right? This is not the way. How do you do a experiment or study science? So we shall find a simpler way to get the balance, and you don't want to miss it in between any of the 2 points also. For that case, P by Q you are not going to change. In the place of resistance R and S, let's employ a wire to simplify the process. You know, resistance of a wire R equal directly proportional to length, inversely proportional to area of cross section. Rho is called specific resistance constant. Take a single wire, its rho is fixed. Take a wire of uniform area of cross section, its area of cross section is fixed. In that case, resistance is directly proportional to length. So vary the length by each millimeter so that doing your problem becomes, getting your balance becomes much simpler than the doing like this practically. This is the whole idea of why do we get into meter bridge, why don't we live with the Wheatstone bridge, right? We'll further improve this ideology and work with the complete meter bridge itself in the next video. But in this video I just I'm just telling you that why do we need a meter bridge at all, right? This is a kind of a concept that you need to get into your head. Thank you.